right, ladies, we're going to take a look at a second kind of factoring, or actually third kind. We've done GCS factoring, greatest common factor, and then we did a technique called guess and check. We're now going to look at another one called difference of two squares. So before we do that, I want to just take a look at three sample FOIL problems. These are problems we would work out by FOIL. So x plus 3, x minus 3, x minus 5, x plus 5, 2x plus 1, and 2y plus 1, and 2y minus 1. And the first thing I want you to note is how the problems are similar. Okay, first of all, they're both binomials. So these two terms in each one of them. And second of all, you should notice that the two binomials are almost identical. They're not quite the same. They're almost the same. They have the same first term and the same second term, but one is plus and one is minus. Okay? So each one of these has the same first term, x and x, 2y and 2y, the same second term, 5 and 5, 1 and 1. But in each case, one of the terms has a plus, and one of the factors has a plus, and one of them has a minus. This one's got the minus first and the plus second. This one has the plus first and the minus second. So this is how the problems are similar. So what I want you to do now is to look at what happens when we multiply these out, because something very specific happens for each one of these problems. All right, so we'll do it together. We're going to use FOIL. If you want to make your box method, you can do that as well. So x times x, first times first, is x squared. X times negative 3 minus 3x. 3 times x, 3x. 3 times negative 3 minus 9. So there's our FOIL for the first one. Like many FOIL problems, these two terms in the middle will add together. And in this case, we have a negative 3x and a positive 3x, so those cancel out completely, and our final answer ends up being x squared minus 9. Instead of getting a trinomial for an answer, we get a binomial. All right, let's look at the next one. X times x, x squared, x times 5, 5x, negative 5 times x, and negative 5 times positive 5. Once again, when we multiply these two together, we get these four terms, and the two middle ones add together. We get a 5x and a minus 5x, which is going to cancel out completely, and we get x squared minus 25. I think maybe you're seeing the pattern now on these problems. We'll do one more just to make sure we are really seeing what they have in common. 2y times 2y is 4y squared. Outer, 2y times minus 1, negative 1 is negative 2y. Inner, 1 times 2y is 2y. And last, 1 times negative 1 is negative 1, minus 1. And here, the two middle terms again cancel out, and we get 4y squared minus 1. So what's special about these is that if you have the problems that are set up where they're two binomials and they are the same first term, same second term, well, one's plus and one's minus, this thing in the middle where the middle two terms cancel out is going to happen every single time. Every single time, these two middle terms will cancel out. So that's what makes these problems a little special. The two middle terms will cancel every single time if the problems are set up like this. Okay, so since we know this is going to happen from the beginning, we can save ourselves a little bit of time and effort. Those of us that are using the FOIL method can just skip over the outer and the inner, because every single time they're going to cancel out. And we can just do first times first and last times last. When we do this, you'll also notice that the first term right at the beginning turns out to be x squared. X squared, or in this case, 2y, and we squared both of those to give us a 4y squared. And our last term, 9, 25, 1, are perfect squares. We had that list of perfect squares we were supposed to memorize before. 1, 4, 9, 16, 25, 36, 49, all the way up to 121. And you'll also notice that the center, that the sign in between the two of them, every single time is a minus. Every single time. And that happens because we're always going to be multiplying a positive times a negative, all right? Problems that look like this are called difference, because there's a minus, of 2, because we only end up with 2 terms in the answer, instead of 3 squares. Called difference of 2 squares. Okay, so that's kind of old stuff, although we've just got this little shortcut thing. Now we want to look at doing these backwards. So when we look at a binomial that is a difference of 2 squares, that is, the first term is a nice perfect square, the second term is a nice perfect square, and the sign in between them is a minus, then we can go backwards to set up that binomial factor, okay? So this looks like, go back to the back page, this looks like the answers that we were getting here. This is x squared minus 9, x squared minus 25, and the one that I have here is x squared minus 4. It's got the same structure. We want the answer to be 2 binomials. Set your structure up. We know that we're going to have 1 plus and 1 minus, and then we need these 2 right here need to be the same thing, and they need to give us x squared. So the only way to get that, they have to be the same thing as x and x. These 2 right here need to be the same number, and they need to give us that 4 right there. So we want to put 4 in 1, even though 4 times 1 works, we want to put the same number in both places. That's what really makes it a difference of 2 squares, having them the same. And then when you check this answer, you can see that you're going to get that 2x and a minus 2x, and that middle term cancels out. Okay? So the big thing here is to recognize that you have a difference, minus, of only 2 things, and each of the 2 things here are perfect squares. You also want to keep them in order. This problem starts with a 1 instead of with a variable, so you need to keep that order when you're setting up your factors. 1 plus and 1 minus, it doesn't matter if you put the plus or the minus first, as long as you have one or the other. Don't put the number in the second slot. The number's in the first slot, so it needs to go in the first slot here. 1 times 1, these have to be the same, give me 1. And then I need 2 things here that are exactly the same that multiply together to give me b squared, b times b. And keep them in that same order or else it messes up the signs. So another one, the next one's also kind of backwards. Sometimes people don't like when the variable comes second, but sometimes the variable just comes second. Nothing we can do about it. So plus and minus, there's another perfect square. What's the square root of 49? 7. 7 times 7. And then m times n. Okay? These are the easiest ones to factor. They're super easy, but you have to recognize them. And that means you need to know that list of your perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Those are the ones that you've done since middle school, and you need to continue to know them. So there's 121 right there. We need the square root of 121. That would be 11. 11 times 11 is 121. And there's an x on it, so put an x with the 11. 11x times 11x is 121x squared. The second term has a 9, and the square root of 9 is 3, but it's got a y on it. So we're going to put a y on the end of that as well. 3y times 3y is 3y squared. Okay, each of these numbers, it says homework here, but today you're actually going to finish this in class. Each of these 8 problems is a difference of 2 squares, and almost all of them have numbers that you should recognize as a perfect square. If you come across one and you don't recognize it as a perfect square, remember that what you're looking for is a square root of something. So if there's a number down here that you don't recognize, like for example 289, when you want to know what number times itself gives you 289, you're going to need to do the square root of 289. This answer key will be posted on bulletin board, so work these 8 problems and then check the answer on the answer key.